Okay, so first we want to make sure that we understand what the basic sine and cosine graphs look like, no matter the period, because it's the same shape no matter what, right? There's like 5 key points. So for sine, normally the period for sine is 2 pi, but no matter what the period is, right, wherever that period ends, you could break that up into 5 parts. So I do the end point. Sine always starts at 0 unless there's a vertical shift. Halfway in between is always 0. And then halfway in between each of those is like your max and your min, which normally, without any transformations, right, is 1 and -1. So the basic sine graph, right, your normal would be up here. This would be your max, and this would be your min. And then I always say for sine, it's like 1 hump up, 1 hump down. And no matter what the shift is or the stretch, if you know that basic shape and you can figure out the period and where that starts, you can use that. So we're going to use that as our base as we do these sine graphs. And we can do the same thing for cosine, is we have our 5 key points. So for cosine, remember cosine at 0 always starts up on the y-axis, because normally cosine of 0 is 1. But again, the amplitude can change that, but I'm not even going to label this. I'm just going to do my 5 key points of where it starts at 0, where it ends, halfway in between, and halfway between that. And then you can apply this to any period, amplitude, shift change. So cosine normally gets its max value to start with, which is normally 1. And then it goes down to 0, down to its minimum value, back to 0, back up to 1. And so that's where you get 1 full period of cosine, and then it just repeats itself. So that's kind of the base as we go into these phase shifts, that you want to be aware of those 5 key points, because that's what I use as we do the shifts. So just a quick review of all the rules for what kind of transformations can we have with sine and cosine. So A, B, C, and D mean the same thing for both sine and cosine. Remember that amplitude is like your vertical stretch, and so your amplitude is just your absolute value of A. Your amplitude is also going to help you with your max and your min for sine and cosine. Remember that period is normally 2 pi, but your B value changes your period. So now your period is going to be 2 pi over B. Right? 2 pi over B. And then the phase shifts, that's the hard part. So remember that the left and right endpoints of one cycle are setting bx minus c equal to 0 and equal to 2 pi. Or the shortcut for finding that phase shift is you're moving c over b units left or right. And it all depends on this sign here, right? The equation says bx minus c. So if it's a minus up there, then you're moving right. If that was bx plus c, then now you're moving left that many units. And we're going to use what we know about the period and the phase shift to set up our 5 key points. So that's where I'm going to get these values from. It's really helpful if you have graph paper, because it's really nice to have evenly spaced points. If you don't have graph paper, you just want to try to make your graph as neat as possible. So you're going to see I have some really nice graphs on here. So here's an example of a cosine one. I think the next one's a sine one. Let me check really quick. Yeah, so I can do one of each. And this is, I mean, pi halves isn't that terrible, but no matter what this is, this strategy will work on graphing these. So step 1 on this, you want to think about your period, your amplitude, your phase shift. You can even think about your max and your min values if you want, as you're doing that, so you can kind of just keep the pattern going here. So I'm just going to kind of list this stuff out down here. My amplitude is the number in front of cosine, which is 3. My period is 2 pi over b, which in this case b is 2, which means if there wasn't a phase shift, that this would just go from 0 to pi, and I could cut it in half and cut it in half again and make that lovely shape that makes cosine. But this one also has a phase shift. So the phase shift is C over B, which in this case is plus, so that's going to be negative pi halves over B, which is 2. Dividing by 2 is the same as multiplying by 1/2. So that means a phase shift of negative pi force. So we're going to move left pi force units. This one also has a vertical shift. I didn't talk about the vertical shift back here, but your D, right? If you add a number outside of a function, it's going to move it up or down that many units, which means that this one also is moved up 1 unit. What does that mean for me? Well, it means that normally the max value that I got for cosine would be 1. Well, now my max value is going to be 3 times 1, because that's the biggest cosine can be, plus 1, which means at that high point now on cosine, I'm going to get a 4. And my minimum value, you don't necessarily have to do this right now, but I think it's kind of helpful. Your minimum value that cosine can ever be is negative 1. So I'm just replacing this cosine value with the smallest it can ever be, which is negative 1, and then plus 1 for the vertical shift. So my smallest point now is going to be at negative 3 plus 1, which is negative 2. So using all of this, I'm going to be able to make a really nice graph. I always make, I don't know if you have pre-made graphs or not, but I always make my graph go by whatever unit my phase shift is. So if I'm shifting it by pi force, I'm going to make each one of these little marks, each little square represent a fourth. So I'm going to mark that down here. So this is going to be like negative pi force. This would be pi force. Then that would be 2 pi force or pi halves. That would be 3 pi force. And think about, normally, if there was no phase shift, my graph, my 5 points, would go from 0 and it would end at pi. But because I'm shifting it by negative pi force, now my graph's going to start at negative pi force. So it's going to start here at negative pi force, and it's going to end at pi plus negative pi force, or pi plus negative pi force means that I know my graph's going to end at 3 pi force. And if you look at that, I have those 5 key points now. So I have my 1, 2, 3, 4, 5, and that's how I can make a full period of cosine no matter the phase shift. So here's where you have to be really comfortable with knowing what cosine looks like. Cosine normally starts up on the y-axis, but we shifted it back 1. So now it's going to start at negative pi force, and it's going to start up at my maximum value, which I already figured was 4. So it's going to start up here. And remember, you can kind of do it however you want, but you end the same place that you start. So I know at 3 pi force, it's going to end the same way. And then it goes down to its lowest value halfway in between the minimum value. So at negative 2 is going to be its lowest value. And you can just plug these values in if you want, but I just use the pattern to do this. And I know halfway in between that, it's normally at 0, but I moved it up 1, right? So normally it's at 0 here and here, but I moved it up 1. And you can kind of check that that fits, that we just kind of, like we've moved it up 1. So this was my x-axis, and now I've moved it up to here. And you can see the amplitude. There are 3 spaces here, and there are 3 spaces here. So you can kind of see that it balances out, that it fits that pattern if you're not sure if you're correct. I'm going to erase all this because it looks messy now. So this is my one period. It looks exactly the same as my other one that I did. And what's really great about having a graph that it's all equally spaced is you just keep repeating this. So you can make as many as you want because it's a periodic graph. So if I count it again, 1, 2, 3, 4, 5, I can just repeat this again, that at the end here it's going to end back up at 1, halfway in between is going to be at negative 2, and halfway between each of those are going to be my zeros, but I moved it up 1. And you could just count by force if you need to label what those are, right? Like that would be 3 pi force, this would be pi, 5 pi force, 3 pi halves, 7 pi fourths. And you could just keep going once you get those first 5 points. So to me, it's really critical that you know the basic shape, and it's critical that you're able to find the period and the phase shift and figure out where do I start, and then what will my new ending point be so that it travels that full distance, which in this case was pi. So let's do one more and see if that makes any sense or not. Because this works for sine and cosine. It really works for any of them, but you just have to remember if you're graphing tangent, tangent's period is pi over b, not 2 pi over b, but the other stuff is the same. So to me, this is about as ugly as it gets with pi fifths. Again, really nice if your graph isn't pre-labeled for you. If it's already labeled as going by pi halves or 2 pi, you have to just kind of estimate where pi fifths would be, because what you're doing in there. It's actually not even pi fifths. It's much uglier in this one. This one's also extra ugly in that it's reflected, and so think about it's flipped. It's reflected in the x-axis, so what was normally your max is now going to be your min. So, kind of doing the same thing I did last time, I'm going to start with my amplitude, which is 3. My period is 2 pi over b, and in this case, b is 4, which means my period is pi halves. It's moved down 1, the vertical shift. And my phase shift is super ugly. My phase shift is c over b. This is minus, so remember it actually means it moves right. So it's pi fifths divided by 4, c over b, which is really a vertical shift of pi 20ths. That's disgusting. So that means that we've shifted pi 20ths. So guess what? I'm going to make my graph go by pi 20ths, which is a very weird way to make my graph go by. And I normally would end at pi halves, right? Again, this is how I always think of it. Normally one full period starts at 0 and it ends at 2 pi, or in this case we're just going to say it would end at pi halves if there was no phase shift. But because the phase shift, this 0, right, is now changed to starting at pi 20ths, and I'm going to end at pi halves plus pi 20ths. So what would that be? 11 pi 20ths? So that would be 10 pi 20ths plus 1 pi 20ths. I would end at 11 pi 20ths. So, that's really gross. I feel like I don't want to make this, like, I don't want to count by pi 20ths on this. I was trying to see if I could, like, squish it in, and you could, but I think I'm just going to go with the counting by 11 pi 20ths and then do halfway in between and halfway in between again. So if I count to 11 pi 20ths, right, that'd be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi 20ths. And that does give me a period of pi halves. And then this is where I don't pick points. I have some students that they just plug in these numbers and check with their calculator to see what they're getting. But to me, I just use the what I know about sine. I know at the starting point it should be 0. I know at the ending point it should be 0. And I also know halfway in between should be 0. So I'm just counting. That's halfway in between, yes? And you could count that and label it if you want. 2, 3, 4, 5, 6 pi 20ths. Or that would be what? 3 pi tenths. which you could see if your graph is pre-labeled as going by pi halves. You're gonna that's gonna be really squished in there to go in there. So I hope that what you're doing, you can label your own. And then halfway in between that, normally halfway in between the first half, it's the maximum, but this one's the minimum. Oh, we didn't do that, but I can do it really quick, right? The maximum and the minimum value, like it's switched on this one. The maximum is going to occur at -1, which means it's going to occur in the second half, because you're going to get -3 times -1 minus 1, or 3 minus 1 equals 2. But that's not going to occur here, right? Halfway in between there would be this value. But that's now going to be my minimum because of that negative where it's flipped over. So that's going to be -3 times +1 minus 1, which is going to give me a -4. So at that halfway point, it's going to go down to -4. And at the other halfway point, which would be right here, it's going to go up to the +2. All right, so I'm going to erase these little tick marks here, but that's just my halfway point. And again, oh, you know what I did? Dang it. Okay, sorry. I've made those at zeros, but hopefully you realize I was wrong on that, because that -1 is not a 0, right? It's normally at 0, but it moved down 1. And I was able to check that because I always know when I'm done, that should be like my new x-axis. So it should be equally spaced, my max and my min. And so that's a great way to check. So just like I did on the last one, I'll show you this. Like if this was my x-axis, I shifted that down 1, and that's kind of like my new x-axis. So I was easily able to see that I was wrong, because now I can see that to my maximum and to my minimum is the same distance. Like it's a distance of 3, or it's my amplitude. And because I messed up, it was easy for me to see that I did that wrong. So that's an easy way to check if you did this correctly. I have some students that just find that starting and ending point, and they just plug it in their calculator to check it, which takes a lot of time, but it works every time. I think using the shape of the graph and just doing the halfway in between and knowing what that looks like is helpful. And again, you just can keep repeating this if you count the same distance. And so you can see that, like, I went over, 1, 2, 3, 4, 5 to get my next 0. So I could go back this way, 1, 2, 3, 4, 5, and that would be my next 0, which is moved down 1. And halfway in between that, because sine is opposite, it's odd, it would be up at 2. And I could go over 5 again, 1, 2, 3, 4, 5, and get another 0. And halfway in between would be my lower value here at -4. And you can see that it just repeats itself. So once you get that shape going, you just keep repeating it, and make sure you label your x-axis so that whoever's looking at it can see that that's what each of those tick marks are, because that's kind of an important part to graphing the phase shifts. Good luck.